Hi, everyone, and welcome to the Trustworthy AI for MLOps workshop. My name is Jonathan Messiha, and I'm with my colleagues Courtney Branson and Daniel Fleck, and we are data scientists on the Data Science and AI Elite team at IBM. Today's workshop is a hands-on demo, so we encourage you to follow along with the presenter. We've also provided prerequisites for this lab, so if you haven't had a chance to complete it, please try and do so during this introduction. And if you have any questions, also feel free to just leave your questions in the chat. Okay. There are rising concerns with brand reputations. As popularity and usage of data and machine learning and AI grows, so does the importance for model trustworthiness and explainability, as you can see from the headlines in this slide. AI governance is becoming increasingly important for enterprises. While there aren't many regulations today with strict rules for AI, they are starting to pop up. The most formalized one is SR 11-7, which is a set of guidelines around model risk management in financial services. It describes the model validation process and ownership required for any model coming from a financial service company. Next, European Union released guidelines last year around AI development and are actively working on stricter regulations. And in Canada, Canada was one of the first countries to establish a national AI strategy and now requires all public agencies to do an impact analysis on AI models before they are built. So what does it take to trust the decision made by a machine? First is fairness. We want the decisions and results to be impartial and to address bias. Our privileged groups at a systematic advantage compared to other groups, for example. Next, we want the model to be robust. Is it capable of handling exceptional conditions effectively? Can we evaluate and defend against a variety of threats? Next is privacy. Do we protect the confidentiality and integrity of our data and meet business compliance? How do we ensure that owners retain control of data and insights? Then we have explainability. So how easy is it to understand the outcomes of our model? Why did the AI arrive at that specific outcome? And what could have been different for it to result in a different outcome or different result? And then lastly, we have transparency. So it's the openness to inspect facts and details, like can we increase the understanding of why and how AI was created. Now we have guardrails against AI bias. Each step in this framework works independently from one another. However, each subsequent step has potential to fix the bias leakage from the previous step. Thus, having bias correction at runtime at the last step is one of the most critical steps since it provides the outermost guardrail. That's why Watson OpenScale monitors models for bias at runtime. Okay, before we get into the actual demo and hands-on portion, I'm going to read out the use case for the data set that we'll be using during the demo. So traditional lenders are under pressure to expand their digital portfolio of financial services to a larger and more diverse audience, which requires a new approach to credit risk modeling. Their data science teams currently rely on standard modeling techniques such as decision trees and logistic regression, which work well for moderate data sets and make recommendations that can be easily explained. This satisfies regulatory requirements that credit lending decisions must be transparent and explainable. To provide credit access to a wider and riskier population, applicant credit histories must expand beyond traditional credit, like mortgages and car loans, to alternative credit sources like utility, mobile phone plans, and even like education and job titles of the person looking to get a loan. These new data sources offer promise, but also introduce risk by increasing the likelihood of unexpected correlations, which could introduce bias based on the application's age or gender or other personal traits. The data science techniques most suited to these diverse data sets, such as gradient boosted trees and neural networks, can generate highly accurate risk models, but at a cost. Such black box models generate opaque predictions that must somehow become transparent. To ensure regulatory approval, such as that from like Article 22 of the GDPR, General Data Protection Regulation, or the FCRA, Federal Fair Credit Reporting Act, managed by the Customer Financial Protection Bureau. Okay. The credit risk model provided in this tutorial uses a training data set that contains 20 attributes about each loan applicant. 2 of these attributes are age and sex, which can be tested for bias. Watson OpenScale will monitor the deployed model's propensity for a favorable outcome, in this case, no risk, for one group, the reference group, over another group, the monitored group. In this tutorial, the monitored group for sex is going to be female, while the monitored group for age will be between 19 and 25. I will quickly go over what we'll be covering during today's session. First, we'll be importing a machine learning model onto Cloudpak for Data. We will then deploy that model. Then we will provision Watson OpenScale and configure the payload logging database and the machine learning provider. We will then score the data, then prepare the deployed model for monitoring. We will then configure the payload logging, quality, fairness, and drift. Then we will submit feedback data and then view the quality metrics. And then we will score data and view the fairness metrics before then explaining a transaction. Okay, I will now hand it off to Daniel, who will start off the hands-on portion of the lab and workshop.
Yeah, thanks, Jonathan. I'll go ahead and share my screen. All right, so as Jonathan mentioned, our demo is going to focus on IBM Watson OpenScale, which is a platform that helps with explainability, understanding, being able to monitor your models for drift, bias, things of that nature. So we will go into actually setting up, deploying a model, and then once we deploy that model, we will then use Watson OpenScale to monitor that model and be able to explain transactions using it. So once again, IBM Watson OpenScale is an open platform that helps remove barriers to enterprise scale AI. And the main objectives that it benefits with is it helps to measure performance of your AI models and its impact on the business goals, and helps to monitor those over time, tracks actionable metrics in a single console, being able to explain your AI outcomes, detect and mitigate harmful bias, accept feedback to compute accuracy measures, and accelerate the integration of AI into your application. So we'll be going over all of these things within the demo. So we'll start off with the prerequisites. So we sent out some prereqs beforehand, and we also sent out the demo lab. We understand that some of you guys are joining today. So we'll quickly go over some of the prerequisites of setting up an account. So when you go to set up an IBM Cloud account, we understand that you need to put in your credit card information. That's actually something that's relatively new. So we weren't aware of that until pretty recently. So we weren't able to get a code for you guys, unfortunately, that actually would let you bypass that. But the good thing is that if you are comfortable putting in your credit card information, you will not be charged, because we will be using all the light services with this, and they're all free. Otherwise, if you're not comfortable with that, we completely understand. And we will be showing the demo as we go along and showcasing all the aspects of IBM Cloud and IBM Watson OpenScale. So we'll go ahead and get started with the prereqs. So once again, these were shared beforehand, but we'll quickly go over them if some of you guys are joining today. So within this Watson OpenScale Lab document, you can click on this link that will actually download the prereq document. Actually, let me, if I click on it, it will download here. And I've actually already got it downloaded, but it looks like this. So we'll have the account setup instructions to be able to set up your IBM Cloud account and set up the services that you need in order to do the demo and use Watson OpenScale. So we'll start with the beginning of this prereq file and quickly go over it. So let me move this over. So the first step in this demo is just setting up an IBM Cloud account. So if you don't already have an account, you're going to need one in order to set up and work on this demo. So as this mentions here, you can go to cloud.ibm.com/registration, which will take you to a screen like this. Here, you can create an account using whether that be your work email or your personal email. And then just follow the instructions here when it comes to verifying that email, personal information, etc. And you'll actually get some credits. So we're actually using all light services, which like it has limitations on what you can do, but it's not going to charge you. But this also actually gives you some USD credits as well to use with a new account. If you already have an account, what you can do is you can just click login here. I'll actually click that. And then it will take you to just an IBM Cloud login screen. I've actually already logged in. I'm already logged in on another tab, so it just automatically logged me in. And it'll take you, this is the IBM Cloud dashboard. So once you've created an account or once you've logged in, this will be the view that you see on IBM Cloud. Okay. So let me go back to the document. Okay. So the first step, once again, is just setting up IBM Cloud, setting up your IBM Cloud account. So you need to go to that link, confirm your IBM Cloud account, and then once you have done that, scroll down, you'll have to confirm your account. You can then log in to IBM Cloud. And you'll just have to kind of complete these, accept these conditions, proceed, and look at this acknowledgement. And then from here, you'll need to set up a few services before the demo in order to complete the demo. So the first step is just setting up an Cloud Object Storage account, which is needed to be able to upload the document into storage and then be able to reference or upload your model or data into storage and then be able to then grab that model from the Cloud Object Storage bucket and deploy it. So we'll go and do that. So first, in order to create and set up a Cloud Object Storage instance on the IBM Cloud dashboard, you can just click Create Resource. So this is going to be what you're going to do to set up any of the services within IBM Cloud that we're going to set up. And within here, you can just search for Cloud Object Storage.
Daniel, can I just pause you for a second? The screen is pretty glitchy. It's hard to follow. Can you maybe, it's like we're seeing both the document and the browser at the same time. So that's clear. I can see your browser now.
All right, let me see.
Sorry about that.
Can you see my full screen now?
I can see the Cloud Object Storage page.
Okay, let me go back. Is it okay? I'm seeing things glitch. Yep. So I'll just monitor myself a little bit more on the screen because I can see it's definitely a little glitchy here. Not quite sure what's doing that, but let's do that. Okay. So yeah, so I'll go back. This is where you can go to set up any sort of instance or use any resource within IBM Cloud. So we want to set up a Cloud Object Storage instance. So we can type in Cloud Object Storage, search for it. And here you can see this is what we want to set up. This object storage instance provides flexible, cost-effective, and scalable cloud storage for your unstructured data. So we want to set up this. So I'll go ahead and click that. See that it's still a little glitchy. Not really sure why, but okay. So within here, in order to set up your Cloud Object Storage, you just have to complete a few minor tasks. So first, if you already have a Cloud Object Storage instance, whether that be you've already have an IBM Cloud account or you've already set this up, you don't need to set up another one. You can only have one here. You can only have one instance of a light IBM Cloud Object Storage instance. So once again, this light plan, we're all going to be using light plans. So they are free to use, and you can only have one instance of a light Cloud Object Storage instance. So if you already have one, then you aren't able to set up a new light plan, so you can just use that one later on in the demo. In my case, I already have one, but I'll show you what you need to do in order to set one up. Really, you would just choose IBM Cloud as your infrastructure, choose light as the plan, and then you would just configure your resource. You could keep the same name for the service here. You could change maybe the end of this to something that you prefer. And then just keep the default resource group and click create. So really simple, setting up the Cloud Object Storage instance. Really setting up all of the services are really simple. But that's the first step, is we need to set up a Cloud Object Storage instance so that we can store our training data and model, and then we can reference that later on. So now I'll go back to the IBM Cloud dashboard and set up our next instance, which as you can see in the demo, and it's a little glitchy still, but the next step is setting up that Watson machine learning instance, which would be, again, we are going to create a resource within IBM Cloud that is for Watson machine learning, and then we will use this later on. Watson machine learning is used to deploy your models so that they're able to easily be scored via an API, and it really makes it easy to go from a developed model to actual deployment in production. So I'll go move this back over. So once again, at the top right, I know it seems to be glitching here still, but there is that create resource button. I just thought that may help. There's a create resource button that is at the top right, pretty much right where you see my mouse. It was the one that we just selected earlier. And that's how you're going to set up a resource instance again. So we just set up Cloud Object Storage. We're going to follow the same instructions this time, except instead of for Cloud Object Storage, we're going to set up the Watson machine learning service. So once again, we're just going to type in Watson machine learning, which is the name of the service. So here you can see this is the service we want to create. Watson machine learning, it helps to deploy, manage, and integrate your machine learning models into your applications and services in as little as one click. So I'll click this. This is the service we want to set up. And yeah, really similar steps as before, slightly different, where this time it's going to ask us, what is the location where we want to deploy our service? I would just use whatever the default is that it's showing you, unless it's not the closest location to your current location. So I'm just using the North America location, as I'm in North America. And then once again, I'm going to use the light plan, which is free again. So we're using all free services. And then as you scroll down, it has a service name already created for you. You can change this if you want, and then you can just select the default resource group. And then you just need to click, I've read the instructions or read the license agreement, and then click create. So once again, you can actually create multiple instances of Watson machine learning of the light plans, but if you already have a light plan set up, there's no need to create another one. You can just use the instance that you already have set up. So I already have an instance set up. I just won't click create because that's really the last step, is you're just creating it, but I already have one. So you would just follow these instructions once again, click create, and then that would create your instance of Watson machine learning. Once again, I'm going to bring this back over. I know that it's still, you can't see the top, but I'll just show you guys what our next step is going to be. So lastly, you can see our next step is going to be setting up Watson Studio, which is an IBM service where you can develop models and do more experimentation. And then from there, you would deploy them using the Watson machine learning service. So this is really the last step, is just setting up this last instance. This is the last step of the prereqs, and then we can go into the demo. Okay. So we will go back to the home screen again. We click this IBM Cloud button to go back to the dashboard. And once again, the same instructions. We're going to create another resource. So we will click this create resource button. I know you guys can't see it, but we'll click this create resource button in the top right. It's right behind that black bar that won't disappear. And next, we will then just, once again, search for Watson Studio, which is the last service that we need to set up. So here it is. Watson Studio helps to develop sophisticated ML models using notebooks and code-free tools to infuse your AI throughout your organization. So this is what we're going to be using to create our model and then deploy it using Watson machine learning. So same steps as before. We just need to quickly set up a service if we don't have one already set up. You will use the location closest to you. And then the light plan again, this is free. And then the same steps as before. It already has a Watson Studio service name for you. If you want to change the name, you can, but there's really no need to. And then click I have read and agreed to the following conditions, and then create. Once again, if you already have, I've worked on IBM Cloud before and you already have this service set up, you can just go ahead and use the one you already have. So that's really just the prereqs there. It's just setting up those three services, and then we can move on into the actual demo. So I'll go back to the IBM Cloud dashboard, and I'll actually bring over, I'll bring over the lab, just to show you guys where we are with that. So we've completed the prereqs, and then these are the objectives, as Jonathan mentioned before. I won't reread these. And then the use case. If you guys have any questions about the use case, again, you can review that. Next, we're going to be downloading the files for the lab. So once again, you can just click that link and it will just download it as a zip file. So here, let's see. Will be downloaded as a zip file. When you unzip it, it'll look something like this. So it'll have 4 files within it. It'll have feedback data, which Courtney will go over in the upcoming demo, what that's going to be used for, feedback with your model. Payload, which is going to be scoring for your model. Your training data, and then your scoring JSON, which are actually going to be like trying to score the data. So these are just the 4 documents that you need for the lab. So we'll go back to the demo. So that step is really just downloading those files. And then here, you'll just follow the instructions of downloading and unzipping a folder. So you'll download it, you'll click on that link, and then you'll unzip it, and then you'll have those 4 files access to be able to use in the upcoming demo. Okay, so I won't go over all that. That's just really just extracting from a zip file. Okay, so we'll start from here. So importing the training data to the Cloud Object Storage instance. So we're going to go back to our IBM Cloud dashboard. So the first step is we've already created the storage instance. Now we need to import the training data so that we can reference it later. So from within the dashboard, you can click the top left, and really wherever you are within IBM Cloud, if you click on this, then it will show this, you'll have this side toolbar. So here you can click on this top left button and it will take you to the side toolbar. We want to look at resource list. The resource list shows you all the resources that you created. So those are the service instances. We've got the Cloud Object Storage. We have that Watson Machine Learning Service instance, Watson Studio. So I have more than what you guys have created just from other projects that I've worked on. But if you've ever created a service instance under your, under this account, you will have, it will show up here. So here, we want to find Cloud Object Storage. So within here, our Cloud Object Storage just is, we need to look for the storage resource. So under here, we have one Cloud Object Storage instance. That's the one we're going to use. So if you, once you created yours, it will show up here. And you can also just type Cloud Object Storage within this filter if you're having trouble finding it. And then you will click, you'll just open it. So within here, we want to create a new bucket within this Cloud Object Storage instance. So you may use different buckets in order to, if you're using them for different projects, you can set permissions around buckets within a storage instance. So we want to create a bucket to store the data for this specific demo, and then we can access that bucket later using the bucket credentials. So in order to,
Daniel,
yes.
Sorry, do you mind maybe trying to minimize the Word documents? We can't see. We're
are they still on
comments.
the page?
It's a little distracting. Yeah, they're still on the page for us, unfortunately.
Oh, sorry. Yep. Interesting. Yeah, I can minimize those. Actually, sorry.
Yeah, we can see the screen now.
Okay. You can see the full, okay. It must be something with me using multiple screens and it's like using half of my other screen. Sorry about that,
yep.
Guys. Okay. All right, so that next step is just creating a bucket in this Cloud Object Storage instance to save your data. So we will click on this right button here, which is just create bucket. If you already have a bucket, you can use that specific bucket, but it's easier to just create a new one and then we can set up the credentials as we go. So we want to create a bucket to store our training data. So the quickest way to create a bucket and then actually also create credentials around it to reference it later is just going to use this predefined bucket quick get start section right here. In this section, it will actually set up the credentials for you, and then you won't have to go ahead and set up credentials, and then you can reference those service credentials later to be able to query data from this bucket. So you can just click quickly get started. Next, it will say you want to create a unique bucket name. So this Cloud Object Storage bucket needs to be unique across all buckets created. So if this will just go ahead and give you a unique name. If you have a name in mind, like you could use Cloud Object Storage credit risk, which is the use case, and then maybe your initials or something, or I'll do just 2 numbers, then you can create it that way. And then you need to select next. So on this screen on the left, you can see it says drag and drop files to upload to the Cloud Object Storage bucket. So here we just need to drop the training data file into the bucket that we are that we have just created. So what you'll do, and it looks like now it's loaded, what you'll do is you'll go to that you'll bring in that training data, German credit database bias training, and you'll just drag and drop it here. Once you dragged and dropped it, it'll really quickly upload because it's not a large file. You'll see it says upload success. And then once it's complete, you can just click this X here. If you want to if you were on a different project, you wanted to keep uploading files, you would just keep uploading. Then you would click next. So here, this is just a screen that we're almost done creating the bucket. And this is just a screen that says if you want to test your bucket, this is optional. Then you can use this script to essentially test your bucket. So we're not going to test it today. You can if you want, but we're just going to move forward with creating the bucket. So lastly, at the bottom right of the screen, you will see view bucket configuration. So we'll click this, and this is actually just created the bucket. So you can see at the top right, I know a little bit of it's cut off, but it says the bucket is created successfully. And then these are the bucket credentials we have here. This is the bucket name. If we scroll down, we have the service. It's created these service credentials. So if you want to later on access, be able to like reference the data that you've uploaded here, you're going to need these service credentials. You can also find them later, but API key and resource instance ID are the two credentials you'll need to actually reference the bucket. And these are all the details for the bucket that you have here. If later on, if you leave this screen and then you want to go back in and access data from within a given bucket, what you would do is you would just go to that Cloud Object Storage instance, and then instead of going to the Buckets tab, you would just go to the Service Credentials tab, and then find your bucket. So with the bucket we just created, we'll just search for is Cloud Object Storage Credit Risk, and then these are the credentials for that bucket. So this is kind of how you would reference it later on if you need to query and access data from that bucket. So that's the first step, is importing your training data into the Cloud Object Storage instance. So we'll go back to the IBM Cloud dashboard. I'll take a few seconds, see if it loads a little bit better. I know it's being a little slow. But so the next step is importing our credit risk model into Watson Studio. And then once we have imported that model, then we can deploy it into Watson Machine Learning. Sorry, give me 1 second. Okay, so I know it's kind of, the screen is not cooperating with me at the moment. But once again, we just need to go and find our Watson Studio instance. So it's good that you can still see my mouse. At the top left, you can click the top left tab that we showed you guys before. And this will bring out a drop down. From here, you can click right here. There will be something that says resource list. And thankfully, these screenshots are all in the demo. So if you have any questions, you can just reference the demo document. So you can click resource list, and this will give you, once again, all of the resources that have been created. So the next step is we need to import the model into Watson Studio, which is where we are actually the service instance where you create models. So we just need to search for this, and we just use this filter here. And then it looks like you can see the Watson Studio instance that is there. So we can just click on this and then enter Watson Studio, and then import the model that we have. So I'm going to go ahead and click on, I'm going to open this in a new tab. And I know you can't see the top here, but really what's important is this launch in IBM Cloud Pak for Data. So this is where we are launching this service. So once you click into this, it will launch Watson Studio within Cloud Pak for Data, which is a all-in-one platform for being able to use these different services. So you can click on this launch in IBM Cloud Pak for Data here, and then it's going to provision your service. So pretty quick to be able to do that. And then this is IBM Cloud Pak for Data. So within IBM Cloud Pak for Data, you can use, we are using this Watson Studio service. You can also use Watson Machine Learning service. This is where you can use other Watson services within IBM Cloud Pak for Data. This makes it easy for your teams to be able to, an all-in-one platform, be able to develop models, do exploratory data analysis, deploy those models, monitor those models, etc. So the first step is going to be creating a project. So you can create projects within this platform, whether that be for different teams, different organizations, etc. And you can set access rules around those. So it's really easy to be able to work on multiple things within one platform. So you can see here, I already have a lot of projects that I've created for different demos. And what I want to do is just first, I want to create my own project so that I can import my model into that project. So here you can see it says create a project. So you'll just click on that link. So there are two options. You can either create an empty project or you can create a project from a file. So creating a project from a file is if you already have a project and you've exported it and you want to import it somewhere else. So we aren't doing that. We're just creating a new project. So we want to click on create an empty project. And here at the top, I know you can't see it with my mouse, but this is going to be where you have the project name. So there is a screen. Once again, these screenshots are in the demo. There will be a section to import a project name. You can put whatever name you want. And then you can also provide a description so that you can provide a little bit more detail around the project that you're working on. We have a Cloud Object Storage instance associated with this because when you're uploading anything to this project, it's being stored there. If you have multiple instances, you can choose between the one, but we only have one instance of Cloud Object Storage. It's the one that we created previously. And we just need to name it something. So I'm going to call it Watson Studio Lab. Let's say demo. So once again, here, I know you can't see it, but that's just where you would name the project. And then you can click create at the bottom right. So here, we've created a project. And within this project, you can upload data. You can create Python or RStudio notebooks. You can upload different database connections to be able to work with them. So what we want to do is we just want to upload a model to be able to deploy and then monitor it later. So we have assets. We have, I don't know, you can't see the word assets here. And then we have the assets tab. We have jobs. What we want to do is we want to add an asset to our project. So from here, we're just going to click. We're going to go to the overview or the assets tab, sorry, which is right here. There's just a tab at the top that says assets. And we want to add a new asset. So we'll click on new asset. It's asking us what type of asset are we adding. We want to just add a model. We can add connected data, database connections, any sort of imports. We want to add a model that we are uploading. So we'll click the word model. From here, if we had a XML file that we are uploading, so if we trained a model somewhere else and saved it, we can upload it. But we're just going to use a sample model that is provided within IBM Cloud Pak for Data, so you can do demos like these. And this is the credit risk demo model. So we'll just click on gallery sample, which is right here, and then click on this credit risk model, which is right here, and then click next. So we want to add this model to the project. It's then going to ask us a name. What is the name for it? We can just call it credit risk. And then it already has a description. So we can continue and just add that to the project. So now it takes us to the screen of the model that we've just created. So this is the credit risk model. We have an ID for the model. We have details on when it was created, by who, like the training data, etc. So it provides a lot of details around like the metadata, for example, the input schema for what is input in the model, and then what is the output schema going to be? It's just the entire input plus the prediction and the probability. So the next step is, right now all we've done is import a model. We need to now promote it to a deployment space. Essentially what's going on there is that if the model is just saved within this project, it can't be used and scored externally. So next we need to save it into a space within Watson Machine Learning and then deploy it. So deploying it will create an API where you can actually score it externally. So promoting it to a deployment space is the first step to be able to save it in a space that can then be deployed. So we can create a deployment space for different projects, for different organizations, where you can limit who can access your models within Cloud Pak for Data. So really we just need to click, there's this button at the top right. This is promote to deployment space. We'll click that. And then we need to promote it to a specific deployment space name, which is essentially like a folder that can store a lot of models or assets that you want to deploy. So here, let me bring it down a little bit so maybe you can see. It says, do we want to create a new deployment space or do we want to use one that you already have? So if you already have a deployment space, you can click on that. But we're assuming that you guys do not have a deployment space because if you're new to IBM Cloud Pak for Data, so you can click create a new deployment space. From within here, you could just name it anything you decide. So I'll call it like credit demo version 2. This is the Cloud Object Storage instance that it's using, which is the one that we created earlier. And then we want to like select a machine learning service. This is optional, but like, what is the machine learning service that we created earlier? So we created this. I have created multiple before, but I know that this is the one I created earlier. You'll only see one service here. And then we can click create. So here the space is being created. If we already have one, we can just deploy our we can just promote our model to this deployment space, and then from within there we can deploy it. So it says the space is ready. So we can close that, and then now we can use it to save and promote the model to that space. So this is the space that we're promoting it to. I'm going to click this, which says go to the model after promoting it. That'll just show you where it is. This is the asset that we're promoting. So if you're promoting, it says the name. If you're promoting multiple things, it would show this. And then that's really all we want to do. We want to promote that. So we click promote. So from here, this shows the model, the promoted model that we have just created. So we can click model details. Actually, it looks like the screen's cooperating a little bit. We can click model details here, which gives us details on, once again, the model that we created, the information on the training data, etc. If you click on the deployments tab, this will show you if you've deployed this model before. So if we've deployed it, we can click in and look at the deployment and reference that and find the like API details to be able to score it. But we have not done that yet. We've just promoted it to this deployment space. So the next step is we need to click on new deployment because we now want to deploy the model so that we can score it and monitor it. Click on new deployment in the top right. So we just want to deploy this as an online model. And then you can create a deployment name that you want. So I'll call this credit demo deployment version 2. And then we can just click create. So this is creating a deployment using the model that we saved. So here once again, under the deployments tab, we now can see a deployment here. If we had multiple online deployments, we would see it, and then we can see that it says in status, in progress status. So that means it's currently deploying. Once it is deployed, it will have this green check and say deployed, and then we can click on that. And this will actually give us documentation on, now that we've deployed this model, we can reference it via an API endpoint. We can score it using, we have these code snippets from different programming languages to be able to score your model externally that you have deployed here. So this is that kind of, so what we've done so far is we've uploaded our training data, we've uploaded a model, and then now we've deployed that model so that we can then score and monitor it later on using Watson OpenScale. So now we'll actually move into the important part of the demo, which is around actually going over Watson OpenScale. So we have everything set up now to be able to create the Watson OpenScale service and then show the capabilities provided by Watson OpenScale.
I'm sorry, Daniel, can we pause for just a second? I know a number of people in the chat are having issues finding the model object within the data access tools. And unfortunately, we don't have a ton of time to pause. So if you could DM Jonathan through this platform, and we are going to see if we can get a solution. And in the meantime, if everyone could just follow along with Daniel, because we are going to be running short on time. This is going to take about the full 2 hours. So we apologize for the inconvenience. We're going to try to get a workaround for you guys. And in the meantime, if we could just try to follow along. I know we're going pretty fast here, so we appreciate everyone's cooperation.
So are you talking about the gallery sample? The model under that sample is not there?
Yes.
Okay.
Well, they don't see a model button at all when they go to data access tools, when they go to add the new asset. So okay. We're looking into it in the back end for you, Daniel. Okay. So you can keep going. But we are looking into it. We see your comments. So we're going to try to reach out to you guys individually and see if we can get something figured out. Okay. The last thing I'll say, before, I don't want to dive in too much to that, but I know I would double check you're clicking new asset and there's a new asset and I think there's an add asset. New asset is the one that I clicked, which then you can find the model one. Maybe it's not, maybe different versionings is not available, but I would just double check that. Awesome, thank you. So next we'll go into, now that we have created this, we now need to provision the Watson OpenScale instance to be able to monitor and view the model or monitor the model that we've just deployed. So I'll go back to IBM Cloud, and I just want to go back to the homepage of IBM Cloud because I want to create a new service again. So the same steps that we mentioned before, but instead we're creating a Watson OpenScale service. Once again, we can just select the top left button. There's that hamburger button, or some people call it the hamburger button. And then there is resource list underneath here, which once again is where we created the resource app. And we just need to click create resource from here. And here we can just click Watson OpenScale. So what I did just now is I just want to make sure people, in case people are doing it a different way. So I was within IBM Cloud Pak for Data, and I went back to the IBM Cloud website. So if you stay within this IBM Cloud Pak for Data platform, there is a slightly different way that you will find the service and create it. So I'll actually go back to this way because I've shown you before how you can create it in IBM Cloud. And actually, if you are staying within Cloud Pak for Data, these are the screenshots that I showed within the demo. So this is where I last left off. I've deployed the model in IBM Cloud Pak for Data. You will just click this top left button. And then here, in order to look for the services that you want to create, you'll click Services Catalog. And then just similar process.
Watson OpenScale is what we want to create. So this is creating it within this IBM Cloud Pak for Data platform. So we'll click Watson OpenScale. I actually already have an instance of this, so I won't create a new one, but just the same steps we followed before. We need to choose a region, which is like just the closest region to you. And then the plan, just choose the light plan. And then you can keep the service name the way it is and click create. So from there, we now have a Watson OpenScale service that we've created. So if you have already created one, then you can go and find that instance. So after you create it, I'll just go back to the services catalog. And then from here, like, so if you've already created the instance, where you can find all services you created are just under, you click the top left, and then you click service instances. So services catalog is if you're going to create an instance of something. Service instances shows everything that you've created. This is any current service that you have. So I will just click, I'll just type in OpenScale so you can find the Watson OpenScale instance. And then I'll just click it. So this is how you enter Watson OpenScale. So we've set up the service, and now we want to launch the application and set it up. So from here, we will just click, you can see this launch application button, this blue button. You can click that. And this will take you to Watson OpenScale. So we've actually already like deployed a model within here. So you'll see something already, but if you've never set up Watson OpenScale before, then you won't see anything on the screen, and it'll actually ask you to like complete a setup, and you'll click, it'll say manual setup, and you can actually go in and set up the Watson OpenScale instance by clicking on this button right here. Once you've entered it, you can go in and just click on this, which is an actual configuration of the instance. And then from here, you can set up the system that you've just created. So we've actually already set these things up, but I'll show you the steps that you would need to complete to do them. So we first need to set up a database. This is to collect like payload logging data for when you're scoring it and monitoring the data. So you can just click this button. We've already got a database set up, so you can click this to remove it. But otherwise, you could go in and just choose the free light plan that is available. If you wanted to choose some other sort of database, you could, but you can just use the free light plan database in order to set up where the payload logging data is going to be stored. The next step is setting up your machine learning providers that you are referencing the deployed model from. So here, this is like where you're connecting to those deployed models that you've stored in that environment that we were just talking about. So we deployed our monitors or deployed our models into that environment. And then now we need to set it up so that we can reference those. So we would click add machine learning provider on the right here, this blue button. And then from here, we could just click this, which is going to allow us to edit the connection. So we now want to choose a provider that's been set up. So if you can actually connect to deployed models within different services like Microsoft Azure, Amazon SageMaker, or other environments. So we're connecting to the Watson machine learning service that we set up. This is within IBM Cloud. And then the deployment space is just, these are all the deployment spaces that you've created. So you'll only see one because you've only created one. And then this is going to be how you're going to access the model that you're going to monitor. So you will find it within this deployment space. And then you can choose whether you want a pre-production or a production environment. This is just your choice. We can choose like pre-production, and then we can click save. I'll actually cancel out of that and show you what that looks like. Once you've saved it, it'll just show up here. This will be one of the machine learning providers we've connected to. You can connect to multiple. So we've connected to Watson Machine Learning, and we can now access the models that we stored here. Okay. Okay, next, what we can do now that we've set this all up, we can go to the actual dashboard. So if you click the top left button here, this will take you to the Insights dashboard. So we already have a model set up, but if you did not, you wouldn't see anything here. And here, this shows you the total number of models that you've deployed and monitored. And these are some alerts that we've set up that Courtney will go over in a little bit. And then if we wanted to set up a model, so in this instance, we're going to like reference the model that we just deployed. So we could go in and click Add to Dashboard. So you will have nothing in the screen. Once again, we want to now reference the deployed model that we have so that we can then monitor it. So you can click Add to Dashboard. So here, we actually, so in this instance, we've already deployed all the models that we have. So in your case, let me actually bring over the demo so you can see it a little bit better. In your case, when you click on this screen, you will actually see the model that you've set up, that you've deployed, because you haven't monitored it yet. If we had multiple models that we created, you would see multiple models here, but we've only created one model and then we've already set it up to be monitored. So you will see this model here. This is the one that you deployed. And then you'll just click on Configure, which will then configure the model. And then it will just, that's all you really need to do to connect a model and monitor it within OpenScale. So these are really, this is really just the configuration of a model. And then from there, you will have to, there are other steps to actually configure like different settings around what you want to monitor, whether it be quality, fairness, bias, drift, etc. But so from here, what you would see after that is you would go back to your Watson OpenScale screen and you would see one model here. And then from there, you could then score it, monitor it, etc. So that's all for this part of the demo. Next, we'll go into the scoring and the monitoring of it. So I know it looks like we've got about an hour left. I'll pause really quick. I don't know if we want to just go into your section, Courtney. I know we've got about an hour left.
Yeah, so we should probably dive in again. If you have any questions throughout, you can post them in the chat. Jonathan and I were monitoring it for Daniel's section, and Daniel and Jonathan will monitor it for mine. And we are going to go ahead and keep the ball rolling here. So let me share my screen now. Yes, so what Daniel walked us through was kind of like all of the connections and everything that has to happen kind of on the back end, instantiating services, doing all of that to get us to this point, right? So we have now a deployed model that we're looking to monitor within OpenScale. We have an OpenScale instance up and running. Yours may have just created this, I think was the last step of Daniel's section. And so the next part is going to be actually going and scoring the data. So you are going to want to go back to your deployment. So in IBM Cloud Pak for Data, you'll see the deployment that you had made. So we called ours credit risk deploy here. Yours is probably named similarly if you've been clicking along with us or following the lab document. So you can actually click into this deployment, go to test here. And what this is going to do is it's going to allow you to actually send a sample payload over to your deployment and get predictions out of it. So we do have the credit risk data JSON that you can use for this. So let me pull that up here. Yeah, so we're going to use this credit payload data JSON here. So you can open this up with whatever you want. We're just going to copy everything out of it. So Control A, Control C. And then you can come here. So you can see, you can input your data either manually. You could go in and insert all of these fields. It tells you what it's expecting, a string or an integer, but it's much easier to just do it as a JSON since we've provided the JSON to you. So you can paste all of that in there and then hit predict. So this may take a second. There's, I think, about 200 different payloads. Of course, I have the incorrect file here. Let me come here. So if you guys see that, post in the chat if it's the wrong data file. Oops, that's not it either. Sorry, I have a couple versions of this. I think I'm just using an older one. Okay. Yes. Okay. So yours should be correct. I'm working with older versions that were just locally on my computer. If you just downloaded it, it should be the credit risk data JSON. And you should be able to just upload it, the credit payload data JSON. So if you run into issues, please post in the chat. But so you can see here, all the different input data is put in here, and then we get the prediction. So it tells you the fields that it's predicting on, the values for those fields, and then it'll tell you the prediction. So these are the probabilities that are coming out. It says no risk, or some of them may say risk. So these are actually the prediction labels that are coming out. So because we have OpenScale already set up, it's already watching this endpoint. So there's nothing you have to do. OpenScale is monitoring this in the background in order to actually understand the type of data that is coming from it and to really start collecting that type of metadata about the payloads that are coming in, the data it's expecting, what predictions are getting out of it. So it's kind of just a test run of it. So once you've scored that data, you can come back to OpenScale here. And we can start telling it more explicitly what we're expecting it to predict on. So this is what we consider like configuring the model details. So if you come in here, you'll see your subscription that you created. You can come in and hit configure monitors. If you were on that main screen, you may have already been here if you had just created it. And so since ours is already created, I can't go in and do this model input section, but what you would do is you'd hit the little pencil here. You would set the data type to numeric/categorical, and you'd set the algorithm type to a binary classification. And then there should be a button in the lower right that says save and continue. And then the next step is going to be to give it information about the training data. So it already got some from the payload that we had just sent it when we went back to the deployment and we scored it. But it needs a little more information than just that to be able to actively monitor it for all of these different fairness, quality, drift explainability facets. So you're going to go in, you're going to click the little pencil that was next to training data. And this is taking a second to load. But you should be able to go in and manually put in this information. So this is going to be connecting to the training data that we had previously stored in the Cloud Object Storage bucket. So you see here, you can select restricted or a database or cloud storage. So since we have access to that training data, which sometimes you don't, you can hit database or cloud storage. If you didn't, you were just using statistics based off the training data, there is a way to configure it that way, but that's not what we're doing here. Then we tell it that we're using cloud object storage because that's what we set up in the beginning of this lab. And then this is where you're going to need that information, the service credentials that Daniel had pointed out in his section. So you're going to need the resource instance ID as well as the API key. So if you saved those, perfect. It should look something like this. I copied mine out of the service credentials and posted it just in this little text pad. But what you're going to want to grab from there is the API key, which is here, and you're going to put that into the API key, and then you're going to want to do the resource instance ID, which is down here. Copy all of that and put it in the resource instance ID. So once again, hopefully you saved those. If not, it's pretty easy to go back to that cloud object storage. I think Daniel even said had to go back to it in his section, but you go back to the cloud object storage page and you pull those out. So then you should be able to just choose the data set. So we only have one data set stored in ours. This is German credit data biased training, so CSV. So you can go ahead, put all of that in, and then hit save, which is here. Okay, so because we already set some of this up, you see some of these already filled. So it might have had you hit next instead of save in your section. So what you're going to want to do is go through it and answer some of those questions. So it'll ask you to choose the training data label, which you can go in. It should look like this. You hit risk and then you hit save or next. Ours is having us do it in different sections here. So then you give it the training data features. So these are all of the features that it sees in the training data. So we're going to actually want it to use all of these in the predictions just to make things easy. So you can hit the button next to features to choose all of them and then hit save or next. And then there should be a page that'll come up and it'll ask you for the scoring method. So for that, you can choose automatic logging. I think that should be the default. And then you hit next. And then you should be able to choose the predicted label as prediction here. And then probability is probably default labeled as probability. So we're going to want the prediction to actually be the label coming out of it. So that should be the last thing you'll have to configure for the training data. So you go ahead and hit save after all of that. And now all of the model details are complete. So you'll also notice, so all of ours already have the blue check marks because we have already configured this model. But you should see on yours explainability start to load, and maybe even you're seeing a blue check mark there. So explainability actually, once you set up the training data and the model input and all of that, with the OpenScale instance, explainability is actually out of the box, already configured to be able to set up and run on its own. So there's no additional configuring that you need to do there. So that's just something to note, that you should see that little check mark appearing there relatively soon after setting all of these other steps up. So the next one that you're going to want to configure is quality. So we'll do quality next here. So quality is all of these different metrics. So you can see mine are already starting to be listed here: area under ROC, area under PR, accuracy, true positive rates, and so on. So these are all the different ways that you might be interested in looking at the quality or accuracy of your model as it's actively deployed. So you're going to want to configure this. So next to the quality thresholds here, you're going to hit your little edit button. Yours doesn't have these things listed here, so you'll go into edit, and then you'll be able to set these thresholds yourself. So the only one that we're going to change here is area under ROC. We're going to make sure that that is 0.9. And then the rest we can just leave at their default values. We're going to be interested in looking at area under the ROC for this demo. And you'll see some of these use lower thresholds and some of these use upper thresholds. So that's just something to note, that because of the way these accuracy or quality measures actually work, you know, lower values are good for some and upper ones are good for others. You want to make sure that you're doing the right thing for the actual metric you're looking at. So that's just an important thing to note. You're going to need an idea of how these actual quality metrics work behind the scenes, how they're calculated. So after you do that, you should see a button that says next. Again, mine says save since it put it in a different section, but you should be able to go to the next section, which is the sample size. So you need to set a minimum sample size as well as a maximum sample size. So obviously, if you only have like 2 predictions in your machine learning model, doing all of these in-depth quality metrics aren't going to mean a lot, because that's not a that's not a significant sample to be making any sort of quality decisions or threshold monitoring for. So we actually need more samples than that in order to get any sort of meaningful results for quality out of it. So that's setting this minimum. So for us, we're saying about 100 should be fine. And then 10,000 as the maximum, which we won't hit in this demo, but if this was a live online learning deployment, you might want to put some thought into what you actually want that maximum sample size to be. Because it would only take the most recent, for example, 10,000 payloads to actually calculate these metrics on. So after that, you can go ahead and hit save, and that should complete the quality configuration. So after that, again, you might see a little loading icon here for a second before the blue check mark appears, but that should be all you have to do for quality. So next, you would want to configure fairness. So we can go into fairness. And I know when Jonathan was reading out the use case earlier, he already pointed out the two different features that we're going to want to monitor fairness for. So those are going to be age and sex with our data set. So we're going to go in and configure those. So you should see when you click on the fairness monitor, the favorable outcomes here. You can click the little pencil that is next to that. And you're going to want to make sure that no risk. So in our credit risk use case, if you're applying for a loan and you're deemed as risky, that's obviously unfavorable for you. So we just want to make sure that Watson OpenScale knows that. So for no risk, that's favorable. And for risk, that would be unfavorable. So the way you assign these is obviously going to be based off your model, based off your use case, and what you're actually using the predictions for, and so on. So that's going to vary by use case. For ours, no risk is favorable and risk is unfavorable. So you save that, or you hit next. Then it's going to ask you about the sample size, the same as quality. So for fairness, we're actually going to set the minimum sample size to 200, and we're not going to set a maximum sample size. So that means it'll just use everything it has every time it calculates, which is fine for our scenario. So you can leave that blank. So minimum sample size is 200, and then you should be able to hit next. And then it's going to ask you for the features to evaluate. So I've already selected the fields to monitor. So what you're going to have to do is you're going to have to scroll through that list. You should see all the features listed there. And then you're going to want to choose sex and age. So let me see if I can get an idea. Yeah, so this is similar to what you should be seeing. And actually, Watson OpenScale might have already identified those and recommended them to you to monitor. I know they did for me when I was going through this the first time. And that you can see that it actually shows a little check mark like, yes, Watson OpenScale recommends this. So you can go ahead and click sex and age if they weren't selected for you, and then hit save. And then you're going to have to actually go in and configure the monitored groups for each. So let's do age first. I believe that's the first one that'll show up for you guys. So when you do this, you can create your own age buckets in order to look at monitored groups, right? So age in our data set is any number from 19 to 74. Those just happen to be our minimum and maximum values in this data set. So you can set up whatever you think is fair, or this comes with a little bit of domain expertise based on your use case. You're going to want to select things that people and groups that you might think might be at risk. So for ours, we think that the younger people might be at a disadvantage here, so we want to make sure that we're monitoring them for fairness. So as Jonathan said earlier, the ages 19 to 25 are going to be our monitored groups, and then the ages 44 to 67 are going to be our reference groups. So we think that the age groups of 44 to 67 are going to have some sort of advantage over this younger group of 19 to 25. And so that's what we've decided to set this up at. And you might have to go in and create these groups on your own, change these values 19, 25, and then hit add value to make sure that they show up this way. And again, Watson OpenScale might have made some recommendations. If they did, just make sure to leave those blank. Don't hit monitored or reference, and it'll ignore those and just use the ones that you have set here. And then we're going to want to make sure that we set the fairness alert threshold to 95. So after that, you can hit next. And then it's going to ask you to do the same thing for sex. So it should show you this page next. And so it sees that female and male are the only two values that are in our sex column with this data set. And so you are going to want to set the female group as monitored and the male group as reference. Again, this would change based on your use case, but for ours, we think females might be at a disadvantage, so that's what we want to monitor for. So once again, setting the fairness alert threshold to 95, and then saving. All right, so then the last monitor that we need to configure is drift. Again, you see the loading icon. It should check when it gives y'all clear. But while it's doing that, you can still go ahead and click over to drift. So drift monitors two types of changes. So it'll actually monitor for a drop in accuracy as well as a drop in data consistency. And these are based off of training statistics, a bunch of holistic statistics that it gathers based off the training data to actually understand when there is a change in data consistency or the data that it's seeing in training versus the ones that it's seeing live once it's deployed. And then a drop in accuracy is an estimated drop in accuracy, right? So sometimes you have feedback data that is coming back in, and we actually do. We'll upload our own feedback data in a bit, but sometimes you don't. So there's a couple different ways to configure it, but we're going to actually be loading our feedback data in for this demo. But before we do any of that, we have to configure it. So you come in here, you see the drift model over here, and again, you hit the pencil icon. So then we're going to want to train it in Watson OpenScale. You can hit save or next. Yours should say next. And it should ask you to set up the drift thresholds next. It might ask you to wait a second. It shouldn't for you guys since you're doing this all in one step. But when you click this edit button, you should see upper thresholds for both drop in accuracy and drop in data consistency. And you're just going to want to set both of those at 10% here. And then you should be able to, once again, hit the button that says next. That should appear at the right corner. And then it should ask you to set the sample size. So you're going to want that minimum sample size to be 200. And then once again, you can leave the maximum sample size blank. So there's no need to do anything there. And then you should be able to hit save. So you've told OpenScale that we're going to be training in OpenScale. You've set your drift thresholds, and then you've set your sample sizes. And you should be good. So once you hit save, that should complete the drift configuration. So the next step is going to actually be to submit the feedback data and actually view the quality metrics. So to do that, you're going to want to click back up here to go back to the dashboard. And then okay, so then you should be able to go in. So this is our subscription to the deployment once again. So if we had multiple different models deployed, they would each show up as their own box, and you'd see this kind of high-level view of all of these different metrics that we've set up to analyze. Again, yours might be totally blank here. It shouldn't say 9. It should be blank because none of them have run yet. But you can go in and view further details here. All right, so your page will not have any of this because you have not uploaded any data yet. So what you're going to want to do is go to Actions and then Evaluate Now. And you should see this open up. So you should be able to import test data, view endpoints, upload feedback data, and so on. So what you're going to want to do is upload feedback data. So you can click this button, it'll ask you to find it. So you're going to go into your data file here, and then you're going to want to upload this credit feedback data.csv that was in those original data zip files that you had downloaded in the beginning. So we're going to upload this feedback data. So this is just an additional set of labeled data that we have that we held from the training data. So you can go ahead and upload those there. You should, it may take a minute, but you should be able to wait and refresh, and you should see the feedback records show up. So there were 5,000 records in that data set. It may take a second to fully recognize all of them. And so you can keep refreshing if you want to make sure that they appear there. Oh, I did forget a step. So when you're uploading the feedback data, if you went in and you chose the data here and you hit open, it is going to ask for the field delimiter. So it is a CSV, so comma is the correct delimiter for our data file. So once you do that, you should be able to hit select, and then it'll upload all of that data. So then you're going to want to hit evaluate now. And that is going to tell OpenScale that, hey, you need to run all of your different checks, see if there's new data available in order to actually calculate some of these metrics that we're interested in. So this may take a couple minutes after you hit evaluate now, so don't wait, go ahead and hit that if you're following along and clicking along with us. But eventually what you'll see is metrics start to appear in the quality area. So yours likely, because I'm zoomed in, this actually looks a little different than you might see it. But you can see that quality here should be in the middle for you guys. You should see 3, and you'll see quality here. And so you can go in and start to look at and understand these different metrics and how your model is performing. You can actually go into it and you can start to see the chart that appears. And if you click into that further, it'll actually give you the confusion matrix. So I do encourage you guys, especially after this is done, if you have been clicking along and following along, to actually go in and explore some of these areas in more detail, because we don't get the chance to do that too much in this lab as we're helping just to get it set up. But there is additional information that's kind of buried under some of these, so it's fun to kind of go and explore your data a little bit more, explore your model. So hopefully that's appeared now. Hopefully you can see your quality metrics. This is how it should appear for you. It's doing it correctly now, but you can see your different quality metrics there. So next is to actually start to import test data. So this is an online deployment that we're looking at here, but obviously it's not connected to anything on the back end, so there's no payloads that are coming in normally. So we're going to artificially kind of create that for you guys by once again going to the actions button here and hitting evaluate now. So what I want you to look at here is the scoring requests. So you see I have 1,403 because I just went and scored some data via the deployment and so on, but you likely have none. So this is probably a 0 here, 5,000 feedback records. If you do have a couple, maybe you're playing with the deployment earlier, playing with the model a little bit earlier, then you might see some here. So I want you to remember that number, because hopefully we'll see this number increase in the next step that we do. So the next step is going to be go back to that deployment. So here I still have it open from the first time. You may not. You might have to go back to Watson Studio, go back to deployments here, open up that deployment space and go into the credit risk deployment that we had. But if you do have it open, then it should be pretty easy. You come in here, you clear out the fields that were previously there. And what we're going to want to predict on this time is the actual scoring.json. So this is a separate file. It has separate data points than what we uploaded before. And it should be called scoring.json right here. So you're going to want to open that up. Once again, copy all of the information that's in it and then paste it in. And then you should be able to hit predict. See if I have the right file this time. Yes. Okay, perfect. So you see, once again, all the different fields, all the different values. This looks very similar to the first time we did it, except now Watson OpenScale has its monitors configured. It knows exactly what it's looking for as far as fairness goes, as far as drift goes, right? So we've configured it. We told it what to look for. So now every time data comes in, it's going to actually be able to use that data, use the payload data that's coming into the machine learning model, making predictions on it, and actually calculate these different metrics for us. So once you do that, you paste all this information in, you get your predictions out, you should be able to go back to OpenScale here. You might want to open it again, you might not need to, and then you're going to refresh. So before I had 1,403 and now I have 1,603. So there should have been about 200 payloads in that scoring.json. And if you'll remember, 200 was actually the minimum that we needed in order to run fairness and drift. So that was the minimum sample size we needed. So you should be able to hit now, evaluate now, and that will begin the OpenScale process. So normally OpenScale will evaluate every hour, but so if you want more immediate results, you want it to run a quick analysis right now, you can always come in here and hit evaluate now, and it'll go ahead and start running. So after you hit evaluate now, it may take a couple minutes since we've already done this. Ours are already appearing here, so we can take a look at these. But you can see the 3 tests have now been run. So we have one for fairness here that shows the scores is what it's called here, but it's really a disparate impact value for both sex and age. And you can also see metrics coming in for drift. So you can see the drop in data consistency is pretty significant, the drop in accuracy, and so on. So these values will probably look different for yours because I had a lot more scoring data in there. I said I had 1,000 and something, and you'll only have 200. These numbers should look different for you. But that's, more realistic. Models aren't going to look the same. So you can kind of explore why yours might look different than mine. You can, go in and explore all of these in more detail. And in fact, we're going to go on a deeper dive into fairness here now. So to get more information on these, you can click the little arrows in any of the areas. So we're going to look at fairness. And once again, this is going to show you a chart. So because I had data in here before, mine is actually showing as lines here, which gives you a better idea of what yours would look like if you continued sending payload data to it at a future date. But yours will likely just show up as 2 little dots for the current evaluation phase. So you can see here the blue line is the disparate impact values for our monitored group of female over time. So you can see that's actually gone up. So we used to have a 1.2% violation, but actually with the recent data it's seen come in, there's actually no violation. So maybe that's good. You can see the same thing for age here. You can see how it's changed over time. Once again, our threshold line is way down here. We're way up here, so we're performing pretty well. But of course, you can click into it more. So let's go back to sex and let's see when there was a violation. So let's click on the point. Again, you'll only have that one first choice of just choosing those 2 points to click on to get to the screen. But this will give you more information on the bias metrics that were coming in at that point in time. So you see females here had 76% favorable outcomes at this time period, and males had 81%. So when you compute the disparate impact, it's actually the ratio of these. So in a perfect world, you would expect these might be the same. And you can see that they're different here. So you do 76 divided by 81. And that's how you get our fairness score of about 93.8. And again, our threshold was set higher than that, so it was set at 95. And so that's why you see this violation appear. It's saying, hey, this is lower than what you said was acceptable, so we need to look into it. Excuse me, guys, sorry. And so what you can do to actually better understand this is to go in and see the individual payloads that were submitted during this time period. So you can actually see the real data points that were coming in that were contributing to this bias. So to do that, you can click on view payload transactions here. And this gives you all the different specific transaction IDs, what group they fell into, whether they were referenced or monitored. Again, this is looking at fairness for sex. So our reference group was male and our monitored group was female. And then it looks for both group bias and individual bias, which is a key differentiation. Individual bias will compare this data point to other very similar data points, but group bias will group data points based on some characteristic and see if those are performing about the same as other groups. So there are nuances to the way these are calculated, and it'll go ahead and flag these for you. So if we wanted to look at one that was showing bias, we can click on this first one here. It was being predicted as no risk, but with a pretty low probability. So we can go in and explain this prediction. So this is what we call explainability, being able to actually say why the model may have predicted the way that it did. So we can see the features that are contributing to the prediction. So this does use Lime on the back end to come up with these different feature importances. So you can see the highest contributing feature here to the prediction of no risk was others on loan. So because no one else was on the loan, this was seen as less risky. You can see employment duration. They've been there for 1 to 4 years. It was seen as not risky, but you can also see sex because we included this as part of our model just for ease. In a real world, this would probably not be a predictor into your model and into your predictions, right? You would save the sex as metadata and actually do indirect bias, which you can set up in OpenScale, but it requires a couple more steps. So to keep things short here, we didn't include that. But you can see the sex is predicting, which is probably a sign of bias. You can see age is also predicting in the opposite direction. So this person is seen as more risky due to their age, and so on. So this is what we, this is what people normally think of when you think of explainability, getting a single data point, being able to say exactly why this was predicted as whatever it was predicted as. But we also offer what we call contrastive explanations. So this is the Explain tab. If you go over to the Inspect tab here, you can see all of the different features that this payload had. So these are all the features that were in our data set listed on the left here. You can see their original values here, and then you can kind of play with it yourself if you're curious on how something would change this loan application, for example. If they, instead of having no checking, they had greater than 200, and if they were asking for $200 less, then how would that look? And so this will actually predict, this will change the prediction. So this was actually still predicted as no risk, but it did change the confidence. So it made them a little more confident that this person wasn't risky. And the other thing you can do, ours is again already loaded over here, but you would probably have a little blue button that says evaluate now. So if you clicked that, what this blue box over here is going to do is actually calculate the what we call contrastive explanations. So what that does is it actually identifies the minimum number of features that need to change and by how much, in order to get the opposite predicted outcome. So in order for this person to be seen as risky instead of not risky, what would need to change? And they actually found only one field needs to change in order for that to happen. And they would need to have a co-applicant on the loan. So if this person had applied with a co-applicant instead of a loan, it would have been seen as risky and they probably wouldn't have been granted a loan, or that would have fed into a further decision-making process, right? So if you get, for example, in this use case, if you had like an angry customer sitting in front of you, or asking what they could change, like they need the loan, what can I change, what can I do to actually be seen as not risky to be able to get this loan. That's kind of what contrastive explanations helps you find out. So obviously this is going in the wrong direction. Ours is already predicting no risk, but if this was risk and you wanted it to be no risk, then you could do it that way and try to help out the person, or use these for a variety of different use cases depending on your use cases. So trying to think. Okay, so that was the last thing that you'll see in the actual document, in the lab document. But one thing that it didn't cover, and since we have a little bit of extra time, I do want to leave some time for Q&A, so I'm not going to stay too long on it. But we didn't look at drift. So I really encourage you guys, if you have time. I know a lot of you weren't able to click along with us, and so I am glad that we had a little bit of extra time so I can go into this. But this is drift. So if you have time, if you have been clicking along with us, you can go and explore this on your own. But if you haven't, I can show you it briefly here. But this will show you the graphs for drift. So you can see here, this green line is the drop in data consistency. So you see this really drastic drop in data consistency, probably due to having very little data in this model. And then this dark blue or kind of purple line that's hidden by the gray is our drop in data accuracy. And then this red line is the threshold. And so if you want more information on this, you can click in the same way you could click in on fairness, and it'll tell you the different transactions that are responsible for these drops. So it's finding 356 transactions that are responsible for the drop in accuracy. So, there was a 15.2% drop in accuracy. So you'd want to look at this. And what it does is actually does some clustering on the background to understand which features are responsible for these drops. It kind of clusters them together for an easier look. So you can come here and see loan amount is the top one. I'm zoomed in so you guys can read it, but it might be making it more difficult here. But you can see loan amount is the top one here and here. So that's 150, a little over 150 transactions are actually saying loan amount is responsible for its prediction, which was supposedly not accurate. So you can look at that. You can also see installment percent for these two are having some influence or small influence on it. And so it helps you kind of identify which features might be contributing to this drop in accuracy, or more importantly, possibly the drop in data consistency. So you can kind of have somewhere to start if you're looking to solve these problems, seeing what might have changed with the specific feature instead of having to look at the data set as a whole. Because I'm sure we all know, these data sets can get really big and it can be really hard to identify yourself. So this kind of gives you a starting point to actually say, credit history seems to be having some problems. This is a really drastic drop. We need to look into this. Maybe credit history had some noise. Maybe something happened, right, that is contributing to this drop in data consistency. And you can actually click on and do explanations in the same way that we did explanations for fairness. But these are payloads that came in and are contributing to the drop in data consistency. So you can go in, see all of them, explain the prediction the same way you did before, and actually get that data. So I do encourage you, if you were following along and you have this on your own IBM Cloud account, to go in and explore these deeper, try sending different payloads and see how it changes the statistics that are coming out of it, and whatnot. And feel free to reach out to us, obviously, if you have any questions. And I do want to open up for Q&A. So if we have any questions, either in the chat or otherwise, Daniel or Jonathan, if you've seen something that has come up as well, we can go ahead and take some time to discuss.
I'll say, if people didn't see it in the chat, I know a lot of people are running into issues of not viewing the model in data under data access tools. We think it's because maybe the Watson machine learning service has not been set up. If you set up the service and you still aren't able to see it, then we'll keep looking into this, but we aren't sure why you wouldn't see it in that instance. But we think it could be all services are not set up. But I guess we'll take feedback on that if there's anything.
All right, I'm not seeing any questions come up in the chat. So we can probably end early. As always, you can message any of us either through the Whova app, or you can email us, and we'll be sure to get back to you. We want to thank you all for participating. We hope you got a better understanding of how you can actually look at Trustworthy AI. It really can be like a pretty seamless part of your end-to-end workflow. You know, this isn't, if you're already building the model, you're already putting in all the work to data clean it and stuff. This is kind of the icing on the cake, just to give you some peace of mind that it's performing the way it should, that it's trustworthy, it's not, you know, doing anything funky against certain groups of people, or anything like that. You know, you can kind of configure it and set it up pretty easily to just monitor your deployments and ensure that it's trustworthy throughout its actual deployment. All right, thank you all. Talk to you again soon. Bye.
Thanks everyone for attending.